Next chapter is PERT and CPM. It is the most important chapter in our compulsory 5 or 6 marks questions from this very small topic. And the best textbook here is Quantitative Techniques by ND and Vora. In quantitative techniques in management by ND and Vora, PERT and CPM. What is PERT? PERT is nothing but program evaluation and review technique. Program evaluation and review technique. Okay. What is CPM? CPM is nothing but critical path method. So PERT and CPM both are used for project planning. Any project. What difference between PERT and CPM? PERT is probabilistic. It is probabilistic. CPM is deterministic. PERT is event oriented. Active CPM is activity oriented. PERT is 3-time estimate. CPM is single time estimate. PERT is used in R&D projects. CPM used in construction projects, non R&D projects, not only construction, non R&D projects. PERT is suitable for new projects, fair new projects. CPM is suitable for repetitive projects. That's the difference between PERT and CPM. What is event? Event is nothing but specific instant of time or specific moment of time. It does not consume any time and resource. Activity. Activity consumes time and resource. Next, dummy activity. Dummy activity does not consume time and resource, but used for precedence relationships between activities. Network rules. Scientist Fulkerson has given few rules on network building. First rule: between two events, only one and only activity can be shown. Between two events, only one activity can be shown. A and B are events and C is a activity. The starting point is called tail event and ending point is called heading event. The starting point A is called tail event and ending point B is called head, head event. The length of arrow and angle of the arrow doesn't have any significance. Second point. The length of arrow, which is shown as C, and angle of arrow does not have any significance. Two events, only activity is shown. If more than one activity want to show, dummies has to be used. To show more activities between two dummies, between two events, dummies has to be used. If n activities are to be shown between the two same events, then n minus 1 dummies are used. When several activities are converted into one event, converged in one event is called merge event. So there are different activities coming and merging. It is called merge event. When several activities diverge from the event is called burst event. Is called burst event. Events are numbered by Fulkerson rule. The tail event number is always less than the head event number. Events are numbered by Fulkerson rule. The tail event A number is less than the head event number. These are the few rules about Fulkerson and few other definitions. Earliest start time EST. It is the earliest time at which activity can start. It is the earliest time at which an activity can start. Earliest finishing time. It is the earliest time at which an activity completed. EFT is equal to EST plus duration of that activity. In a merge event, EFT calculated in all the paths and maximum of it is taken as the EST for subsequent activity. In merge event, maximum of all EST in a merge event, EFT is calculated maximum value of EFT of all merge events maximum the merge event the maximum value of EFT of all events is taken as as the est of for subsequent activity. Lft, latest finish time. It is the maximum time at which an activity is completed. It is the maximum time at which an activity can be completed. LST, latest start time. It is the maximum time at which an activity can be delayed for short without affecting the project completion time. It is the maximum time at which an activity can be delayed for start without affecting the project completion time. Next is LST is equal to LFT minus duration. Next is total float. It is defined as the cushion time that is available for an activity total float equal to LST minus EST or LFT minus EFT. As I mentioned in first definitions, PERT is probabilistic time model, program evaluation and reviewing technique. There are three times which are used in PERT. Sorry, there are three times which are used in PERT. One is optimistic time. It is the time. It is the minimum time required to complete the activity when every resource is available. Pessimist most likely time. is the time taken as this is the time taken as a to complete activities. It is a time most likely time is a time taken for completing an activity that is the best estimate. It is a time taken to complete an activity time taken as best estimate. Pessimistic time time which is required to complete an activity when every resource is not available. 6 sigma equal to T pessimistic minus optimistic. So standard deviation equal to pessimistic minus optimistic by 6. Variance equal to standard deviation square pessimistic minus T optimistic by 6 whole square. So whenever variance of critical path is the sum of the variance of activities on critical path. Variance of critical path is the sum of the variances of some of the variance of the activities on critical path. What is critical path? The longest duration in a project is called the path which consumes maximum time is called critical path. Whenever any activity in that path is delayed, the total project will be delayed. Critical path. The path of activities for the project constitutes critical path. It is the longest path through the network. The longest path in project network. Standard deviation of critical path equal to variance of critical path. Expected time T equal to optimistic time for T most likely plus T pessimistic by 6. These are all more important. Variance anyway we have discussed. These three time estimates follows na beta distribution. Three times T optimistic, T most likely, T pessimistic follows beta distribution. Whereas project completion time follows normal distribution. The probability of completing a project is given by Z equal to D minus T by sigma Cp. Z is the desired completion time, D is the desired completion time of the project, T is the expected or critical path time estimate, or expected completion time. Based on the value of Z, it will help to decide which level we need to calculate. Probability. What is the probability? Next one, crashing. Reducing project duration by employing additional resources is called crashing. Crash cost equal to crash. In crashing, you need to crash an activity which is having least slope, crash cost slope. Crash cost slope, which it has to be calculated for each activity. Crash cost minus normal cost by normal time minus crash time. We have to crash an activity which is having less crash cost slope. Always crash an activity which is having least crash cost slope and which is in critical path. Always activities on critical path has to be crashed. If you want to reduce the project duration, you want to reduce the duration of the activities in the critical path, then only project duration will reduce. If you get questions, we'll solve